Everything is about making their member experience the best, and to ensure that when you're serving in the military or you're the family of the military, the last thing you need to worry about is your insurance, and especially when things go wrong. So being there for our members is what's most important, and it gives me a lot of satisfaction to be able to be a small part of that mission as we try to use AI to help improve our products and services. But on a personal note, I wanted to include a picture of me and my family. This is us last year. We loaded our 4 energetic boys into the minivan in San Antonio, Texas, and we drove all the way to Washington State to see the national parks. It was awesome. The parks, of course, in Washington are beautiful. This one is at North Cascades Park. We're out there hiking, and we're on the trail, and people count 1, 2, 3, 4 boys. You know, we're just the crew that's there. But if you ever want to test your patience and your endurance and your fortitude, try loading your 4 boys into a minivan for over 30 hours to try to get somewhere. They keep asking me, Dad, when are we going to take a plane? And I say, when your dad can afford to take a plane, we're going to take a plane. So that's been great. We make a lot of great family memories. All right, so let's set the stage a little bit here. So many of us, of course, are familiar with the process of building and training a model. And it, of course, all starts with the data. We know that an AI model is only as good as the data that's going to go into it. And when we have that, then the adage of garbage in, garbage out really applies, I think. And so having good, high quality data for our models is important for us to be able to be successful. But it's perhaps unsurprising if you've lived this experience that 88% of data science practitioners say the thing they spend the most amount of time on is the data and getting it ready for inclusion in a model. And on one hand, I get it, because if you look at a company like USAA, we have a lot of data. There's just tons and tons of data there, mountains and mountains of it. And being able to identify the right data set to be able to include, once you identify that data set, you've still got to clean it to make sure that it's ready for use. And then you've got to combine it with a bunch of other data, all the different features that are going to go into your model. It almost seems like the likelihood of starting from nothing and arriving at a predictive and functioning model is just really low, right? It's difficult to get all the way to that point. And for us, it's especially hard because as a data scientist at USAA, historically, you haven't gotten a lot of support in order to get there. You're kind of turned loose with all this data that you have access to, and you're supposed to somehow build a model out of that. Now, what happens is if you were to look, and this was the case a few years ago, as I'm sure the story is common in many companies, if you peel back that data science workspace that the model developer is working in, and you look, they have a bunch of data sets that they've been working on. Version 1 _ version 2 _ version 3 final. There's a lot of iterations of data sets that a data scientist will go through in order to produce what eventually becomes the right thing. Those data sets are produced and then they remain, and sometimes the model becomes a thing. Other times we move on to other use cases. Sometimes the data scientist moves on to others. And you start to have this phenomenon that I call the scratch data swamp, where all of these little data sets that may or may not have been used in the training of the model are hanging out on all of these shared data spaces and in databases, and it starts to get really overgrown. And there's a lot of stuff, and no one is willing to touch it, to clean it up, because you don't know if it's important. Because if you're like us and tightly regulated in financial services, it's very important to retain your data sets that ended up in a working model. We have to keep our training data sets and everything in between. And so nobody wants to touch the swamp in order to untangle what's there. It just kind of ends up living there. And that describes the state that we were in at USAA a few years ago. We had what I would call the scratch data swamp that was plaguing us. And of course, data governance comes and they get involved in, you know what they say, we're going to clear this swamp. We're going to drain the swamp. And they come and they start taking over. And the pendulum starts to shift the other way, where we no longer have a data swamp, but we have what we refer to as the data museum, where after data governance has gotten involved, you can look at the data, but you can't touch it. And if you can't touch it, you can't really use it to make a model. And so that was the problem then that we kind of swung the other way. And our goal was to try to find a balance between the data swamp and the data museum. And so when data governance comes in, the data scientist comes into work and they think, I'm going to build a model. And then they realize that data governance comes in the way and says, nope, sorry, you are not going to go as fast as you think you are because we're going to have all of these checkboxes and steps. And what's hard for a data scientist is that when you're exploring in that data, you don't know if it's going to result in anything predictive. It's an experiment. And so when people come and are asking a lot of questions about, well, why do you need the data? I'm like, I don't really know why I need the data. I'm exploring. I'll tell you if I find something good, but I don't know at this point. Well, what data is it? Where did it come from? How did you catalog it? Where is the retention? All these questions that as data scientists, we don't yet have the answer to, or probably shouldn't have to provide the answer to yet, unless something actually comes of the effort. And so for us, we wanted to find a balance in data governance that is going to help us with this particular issue of scratch data sets. We really wanted to rethink our approach to it and try to find a better way. The approach that we set out with, I would refer to as tiered governance, where at the very bottom, when I'm just looking and seeing if something is relevant, I don't really need to do a lot of governance with that because I'm not doing much with it yet. All the way to then, hey, this is starting to carry some weight. Now I'm starting to see some value in this. Now I've deployed it all the way into production. That would be when the full governance processes should take place. But in the meantime, I need at least some amount of governance, but hopefully not too much, so that I can avoid the swamp, but stay away from the museum and try to strike that balance right down the middle. So as we set on this journey, we had some principles that we really wanted to adhere to try to make it successful. These 5 principles are the things that may vary for your company. It's not necessarily intended to be an exhaustive view of it, but these are what I would refer to as the critical elements of data governance, particularly for scratch data sets. Obviously, for production, real live data assets, there's going to be the whole rigmarole for data governance that we know about. But what do I need that's basically the minimum viable product to still be able to govern my scratch data sets so that I can feel some peace of mind that I'm actually being a good owner of my data? The first one is security. We have to have security no matter what, because this is real data. And so if I have authorization and authentication, that's a must, right? I need to have that for my data. Additionally, the data needs to be encrypted at rest, encrypted in transit. All of that applies because it is truly real data. For us at USAA, these scratch data environments that I'll be talking about, it is considered part of the production environment, but it's a production environment location where data scientists can actually play with the data. And because of that, we have the full rigor of information security that applies to that environment. So we can't compromise on that. Second thing, stewardship. And for me, this actually means that it has an owner. For a typical data asset, the owner is the person in the business who is responsible for that data. But in a data science and a model training environment, when it's a scratch data set, often that steward could be the data scientists themselves because they know what they're doing with the data, they know what it is, they know the purpose of it. And having that clear ownership then drives accountability so that if I need to track down who do I ask questions about the scratch data set, I have a data steward that I can talk to. That requires a little bit of training, I would say, and the mindset of data scientists because they may not be familiar with being a data steward. And for us at USAA, there are very specific responsibilities that come along with being a data steward. So upskilling and training those who are responsible for these scratch data sets was something that we learned that we had to do. We have to do sensitive data management. Typically, with most predictive models, you don't generally need sensitive data. That's what our feeling is that you should practice data minimization and not even bring in the data because not having the data is the best practice for managing sensitive data. But in the event that you do, we need to maintain our regulatory compliance, which is particularly important for PII data, PHI. We also, of course, have PCI as a bank. And so critically, we need to identify whenever we have those sensitive data elements and be able to make sure that we are managing and governing those appropriately. That applies even for a scratch data set. And I'll talk a little bit about our scanning so that we can make sure that we're adhering to that. Next is lifecycle management. This is the one that I think started our journey because we were in a swamp situation and we didn't have any lifecycle management of our data. So making sure that we only keep the data around for as long as I need it. If it becomes something that is important, I keep it around for longer to meet my regulation obligations for retaining my model training data sets. But if it never ended up seeing the light of day and was just a fit of fancy that we explored with for a little bit on a Wednesday afternoon, then we don't retain that now, and it just gets purged as soon as possible. So having that lifecycle management was a very important one. And then finally, essential metadata. We know for a production data asset, there's a lot of metadata that I collect about that. I mean, it's like for days and days how much metadata, and it's important for that to be automated for a production data set. But I don't need to go quite to that extent for scratch data. So I refer to it as essential metadata, more like data that I can manage in aggregate and say what the purpose is of that data, what I'm doing with it, what model it's associated with. That type of essential metadata is very important. But it doesn't go quite to the level of what I would for a production data asset, where I know right down to the table and column level of every single thing that's there. So finding that balance. This one was probably the biggest negotiating ground with our data governance partners about what is the essential metadata that we do need to collect. And fortunately, that can be evolved over time. So as we decide that we need to collect more of that, we can. So it's been good. So these 5 principles are what we took as we were embarking on this journey to try to solve our problem, the balance between the swamp and the museum. And the result is what I'm referring to as automated sandboxes. I use that word, but we actually internally use a different word. It's called enablement zones, because they're supposed to enable the data scientists to be able to do their work. But sandboxes is also probably more accurate, because it's a place where you can go, you can play around with the data. If it ends up being viable, then it can, be something good for you. And if not, it's rigorously managed and it'll go away. So as we look at this, when we were implementing it, there were 3 things that we really wanted to make sure were true. And these are the opposite on the other side of the data governance principles. These are now the things that we wanted to do to make sure that we have a good data scientist experience, as well as making sure that it worked with the tools that we know and love. So first on this was self-service. Doesn't do me any good if a data scientist can't get started on their own. They need to be able to go in and ask for this thing and then be able to get it and be on their way. We don't want a lengthy provisioning process. We don't want a lot of approvals. We don't want to have to justify. If I'm a data scientist, my job is to build models. I got to be able to have it and have it as self-service. We are still trying to fully adopt this vision for number 1. We're not fully there yet, but it's our guiding star, and I'll share that in the areas to approve. Number 2 is auditability. Having the fanciest governance process ever doesn't do you any good unless you can have your risk partners be able to prove that it is functioning as designed. And so the system needs to be auditable. I need to be able to see who's taking actions in the system, what are they doing, what data went in, what data went out, and then what did I do when it was time to finally purge it. Those logs are very important for us, and we need to be able to see that at every step of the way. Finally, we needed integrations. This is kind of the counterpoint to the data museum approach, where you can look but don't touch. I need to be able to access the data where I, as a data scientist, am working, which means using tools like Domino to be able to access the data like I would any other data within Domino. It can be tempting when we go down these roads to design these systems where the data is so well protected that I can't access it. So being able to access from Domino was one of our key principles. We wanted to make sure we had that integration to be able to make it happen. So the sandboxes, we ended up building them. It was something that we've been working on now for the last year and a half. It's been very exciting to kind of see this come to life. I want to show you the architecture of how we made it happen at a high level and try to go into a little bit of the details there. So to present, this is like zoomed out, of course, a lot and generalized a bit, but here's how we built automated data sandboxes. On the left of this diagram, you see we have the model developers. Their experience is that they go into what we call the enablement zone console, or sandbox management console. And there they're able to take and request the provisioning of a Snowflake database. So I worried when I registered for this session to do this little talk that everyone was going to come away with, USAA learned how to use databases. But it's true. That's pretty much my talk, is that we learned how to use a database. So don't make too much fun of me. But we provisioned a database for the data scientists. But the magic is in all of the non-functionals that go around it, of how that database comes about. because it's provisioned with automation. It has access management automatically controlled so that in that management console, I can register who my team members are and who should have access to that database, and then it provisions that. And then that database then, we'll talk a little bit later of the really cool stuff, but that database is in the same location as the rest of our cloud data warehouse. And so easy access to production data, or a lot of times the data scientist doesn't even have to move the data into their sandbox because they're already in Snowflake. It kind of gets there because you can run a single query that crosses multiple databases within Snowflake. Now, on the behind the scenes of it, it's very important for us to have sensitive data scanning so that if somebody says, I don't have sensitive data, that's cool, but that's not really going to hold up to any sort of court of law, right? You can claim all you want, but if the data's there and maybe in a moment of weakness, the data scientist brought in some data that they shouldn't, and it gets there, we're going to detect that with sensitive data scanning. And so being able to identify that and to know what's there is very important to help us trust, but then also to verify. And then, of course, that automated purge process, it's a very dispassionate, once the data arrives, you are getting purged. Your data is going to be deleted, which has its pros that we keep the swamp from growing, but some cons that we'll talk about a little bit later as well. So overall, what we do then is provision a database. I can access that database using my internal employee credentials. I can load production data into that database, and then I can access it from the tools that I love, such as Domino. Here's a little screenshot of what it looks like. It's just a little homegrown app. Probably doesn't get any more simpler than this. You can see it's our enablement zone console. I got a little button that says I can create my enablement zone. I can see the listing of my enablement zones. We even have different organizations. So like departments can have their own sets of enablement zones, and each department can have its own administrator of the enablement zone so that they can see it. It's just this cool little boutique app, really not that fancy at all, but allows the data scientist to really adhere to that first principle, which was self-service. That was very important for us. Okay, so what is the impact of this thing that we've been building? The things that are going well, of course, the first one is that we have now what I would describe as balanced and appropriate governance, where we're able to meet all of our needs for the data relative to the life cycle state of the data. So I think check the box. That's actually going pretty well. The other thing that's great is that data scientists are able to self-service, which we really believe strongly in that. There's a lot that is to be gained from being able to get what you need to be done without having to talk to too many people. And then with Domino, we can actually seamlessly connect just the way that we would to any other database. So through a Domino data source or anything like that, that seamless connectivity, we didn't invent some other new kind of database, right? It's just a regular database under the hood, which means that it can function seamlessly with tools like Domino. And then finally, we can incorporate that production data using Snowflake and a great feature called secondary roles. If you double click onto the security permissions model of how we work, we create a Snowflake role for every single sandbox that we have. And in Snowflake, you can operate as that role, which allows you read and write access to that. But that role doesn't have any access to any other data in the organization. It's only that sandbox. And so a challenge for us until we realized of Snowflake secondary roles is that how do I access the prod data and be able to combine the two together? But when I use secondary roles in Snowflake, then I can use the read-only role that I have for production and the production analytical assets, and then the read-write role that I have for my sandbox, combine those together, and you've got a winning combo where I can take production data and start to transform it and use some of the power that's within Snowflake. So we discovered a surprise along the way as well. We thought we were going on a journey for sandboxes, and we did. We got sandboxes. We call them our enablement zones. But we also discovered something else, and that is that these sandboxes are a useful container for enabling other things as well. I'm surprised I made it this long in the presentation without mentioning generative AI. I'm proud of myself. But we mentioned that we noticed that these sandboxes actually provide a useful container for selectively enabling other technologies. We're very conservative with this stuff, and so we want to make sure that we manage generative AI from the center, and that when we're working on generative AI projects, we selectively enable those tools so that those data scientists can access it. I say that as a positive here, but my data scientists are like, well, I just want everything, right? So there's always a negative to everything, I realize. But with these sandboxes, it kind of has everything that I need for it. For starters, it has a project lifecycle. That's really useful just in general. It has approvals and reviews where I have those organization administrators that can go and look and see what's in there. I have user management, so I can set the organization of a team. And then it has critically automation triggers. So when I create or deprovision a sandbox, there's these little hooks that I can hook into. And so provisioning access to something like completely separate from the Snowflake database, like access to some LLMs or other things like that, that all can be hooked into the lifecycle of a sandbox. And so we're discovering that not only is it just a data layer, a really cool sandbox thing, but it's almost like the unit of measure for a project team that we can use to provision other cool stuff. That was an unexpected learning that we had on our journey. Now, I hate to say the bad stuff, but there are some things that we have opportunities to improve on because it's definitely not all perfect. I go to conference talks all the time and they talk about how everything's amazing and nothing's wrong and aren't we the best? And we are the best, but there are some ways that we need to improve here. So the first is that I create a data set in my enablement zone and it's great. I love it. I don't have anywhere that I can take and send that. And so promoting data sets to a higher environment is a problem for us still to be solved. Today, the best that we can do is have the data scientists download it to their laptop and then take it where it needs to go from there. But it would be really nice to have a way to take it to the next step more automatically. We're kind of cooking on this idea. Maybe next RevX, I'll be back to tell you how we solved it. But the idea is that we would have the sandboxes and then a separate database that we call like the DMZ. We're kind of military oriented at USAA. But the demilitarized zone where it's like a no man's land, where you can write to it from the sandbox, but then you can't really do much else. And then IT production apps could potentially come and read from that. So a little preview of potentially how we might solve that. Definitely an opportunity for improvement. We thought that data scientists would come and tell us like, thank you so much for the sandbox. I'm done with my effort. And now I'm going to go and voluntarily deprovision it. That was pretty naive to think that. In the real world, people just go there with their separate ways, right? And so having that date when we automatically deprovision it is something that's really important. But you'll notice this is a cool and innovative data layer that we've created that we invented databases apparently. But it doesn't solve the problem of how we can actually reduce the time the data scientists are spending there. It gives them accessibility to that data. But what I started the presentation with is still really the next frontier for us is reducing the amount of time that data scientists are spending in actually transforming and wrangling that data. So that's where the future opportunities come in. I mentioned how we're talking about static asset publication. We call it static because if you're doing it on a recurring basis, then you might as well be a full IT data pipelines. It has to be kind of an occasional thing. How do I accomplish that with the DMZ? Next, feature store. Domino has a great feature store. There's also other feature store options in the market. We're very keenly interested in that. I think that's going to be a big innovation. Question that I get all the time is, if you have a feature store, do you really need a sandbox? And I think you do. But it is more of a data engineering reason at that point. If the data scientist can work with the feature store, the data in its raw form that we usually get it still needs a little bit of transformation before it's going to be ready for that feature store. So I think the sandboxes themselves are going to be an important feature, even with the world of having a feature store. But we're interested in that. The enhanced lifecycle automation, this is what I was referring to earlier, where we have a dispassionate culling process. When the data arrives, your enablement zone gets deleted. Opportunity for improvement. What if someone is on PTO, right? They missed our emails or parental leave for an extended time, right? We don't want to delete data. They come back and they say, my sandbox is gone. I think an opportunity would be for us to have a grace period where we can restore that type of thing. Those type of enhanced lifecycle automations are definitely on the docket. And then this is one opportunity I think is great, is to be able to expand this to more than just Snowflake. Snowflake is great for analytical workloads. We're a big proponent of Snowflake, but that's not the only way that we like to query our data. We're interested in object storage, so having S3 buckets or GCS buckets to be able to store That could be very useful to be able to provision those on demand as a data scientist. And then the one I'm perhaps most excited for is Graph, to be able to have a Neo4j instance or a Neptune Analytics instance that is just spun up for me on demand. Especially in the cloud, it's really hard with cloud governance to be able to have data scientists to automatically get those resources provisioned. Having a management console, it just makes everyone feel nice and cozy when it's all automated and observable. It becomes really powerful. So the idea of expanding to future database storage types is very exciting to me.